Um, so I'll quickly go over these. So in the previous lecture or the topic, we looked at how to identify these nouns and verbs. So nouns generally become the class names, and the verbs become the method names, right? And we also looked at the relationship. So you can draw these kinds of diagrams to show the relationships among the different classes. So these are 4 classes, and you can show uh, the call trace, so to say. So you are tracing the calls, and you are also showing the interactions among these classes. And we also looked at these memory locations. Um, what happens when you reassign the value of or reuse the same variable to point to 2 different memory locations. So the old location, you can no longer reference it. So those are the things that we looked at earlier. Um, and we also looked at the issue of the null pointer exception, right? So if you want some variable to be accessed throughout the class within different methods, so you should move it to be an instance variable. Okay, so in this class, like I said, we'll be looking at the relations, and let me get started with that. So we'll be looking at what is called as UML, which stands for Unified Modeling Language. So we'll be looking at it in detail in a couple of lectures later on. But in this class, we'll at least be getting to know what is the terminology that we use, and the type of diagrams that we can build using these UML diagrams. So UML diagrams are very similar to sequence diagrams in the sense that they capture the relationships between the classes. But in sequence diagram, as the name says, you trace the calls. For example, you put out the exact sequence of calls or method calls that indicate the relationships, right? But here in UML diagrams, you don't do that. You only show what is the state of each object. So in the sense that what are the instance variables, and what are the methods that make up the class. So those are the responsibilities and the instance variables. And then you discuss, or you can also depict the interactions between the classes. So you do that using the lines again, but yeah, we'll see that in the next couple of slides. Okay, so this is an example. So you have a box for each class. The name of the class goes at the top, and then you have the attributes, which are nothing but the variables, and then the methods. So there are 3 sections in each box: the name of the class, the attributes, and the methods. So if you want to depict 2 classes, then you have these 2 boxes, and there are multiple different types of lines. So this is a dashed line, so that has a specific meaning. So if it is a solid line, that has a separate meaning. And then there is also a dashed line with a what do you call the polygon at the end. So we'll be looking at that in the next couple of slides. But this is how a sample or a UML diagram looks like. Right? Okay. So we'll be, like I said, looking at these relationships between the classes, and there are broadly 3 types of relationships. Right? And whatever relationships that we put in the design phase, that should capture the relationships that also happen in the real world. So, for example, when you try to model a car, so you can say that the engine is part of a car, or a wheel is a part of a car, right? But you don't say that car is a part of a wheel, right? So it's not a symmetric relationship in that sense, but something is a part of something else. So that needs to get captured even in the when you design these classes, right? So the other example is you can say that uh, motored vehicle is a type of vehicle, or motored vehicle is a vehicle, right? So in that sense, every motored vehicle is a vehicle, but the other way around is not true. So every vehicle is not a motored vehicle. There can be non-motored vehicles such as say horse cart or cycle. So these are unmotored vehicles, right? So there are multiple different types of relationships, and we'll be talking about them in this class and most likely in the next class as well. Okay. So broadly, there are three different types of relationships, or four, right? So, but we'll be looking at the inheritance separately in a couple of next lectures. But we'll be looking at these three: composition, association, and dependency in this as part of this class and the next class, right? So, okay, so we'll go over one by one. So one is the composition. Um, so this indicates the part of. So let's say you want to say that engine is a part of a car or a automobile in general. So if engine is a part of automobile, then there is this contains or composition type of relationship, right? So the other type is called the association. So you simply it's not contained within the other class, but you simply know about enough information about class B that you can call those methods of class B. Again, so we'll be looking at these examples later. And the third one is dependency. So there is no containership or even minor association with the class, other class, but it simply depends on it. So for example, if you want to uh, let's say instructor is teaching a course. So there is a course class which is independent, and there is an instructor class which is independent. But in order to teach a course, there has to be some relationship between these two. There is some dependency, right? So instructor teaches a course to students. So now there is some relationship between these three classes, and it's not a containership or association. So yeah, but yeah, let us discuss these things in detail in the next couple of slides. So we'll start with the containership, sorry, composition, which is also the containership. Um, so if so, let's say there are two classes, class A and class B, and then there are these corresponding objects of the class. Let's say class A has A1 and B has B1. So now, if you are instantiating B within the class within the object A, so then it's called a containership, right? Because apart from A knowing about B, it can call methods, and if A ceases to exist, then B also doesn't exist. Um, so I'll get back to this after showing you an example, right? Okay, so again, I think it's easier to discuss this if after discussing an example. So okay, let me do that. So let's say you have this project class and a manager class. So every uh, manager looks at a project, and if the manager ceases to exist, then let's say, at least for the sake of this example, assume that the project also ceases to exist. But in the yeah, so in this case, you want to make this as a you want to say project is contained within manager. So the way we do that is okay. Apart, the first step is obvious to make project as an instance variable of manager, and the second step is to create or instantiate this instance within the class of manager. So in the constructor, you are instantiating a new instance, you are creating a new instance of project. So now what happens here is, let's say there is an instance of manager called M1, and you are creating a new instance of project which is P1. So manager M1 is handling project P1, right? So if M1 ceases to exist, P1 also doesn't exist, right? Because you created P1 within M1. So there is so in that sense, there is the life of P1 depends on the life of M1, right? So that is what we talked about here. So if if the manager ceases to exist, then automatically the project also dies, right? So that's what even this sentence means. So if the object of A gets garbage collected, then B automatically gets garbage collected. And the way to represent this in UML diagrams is through this symbol. So A is composed of B. So B's instance is created within A. So then you have this dashed line which doesn't have any direction, but on the side of the composition you have this particular symbol, right? So is that clear? So yeah. So in the case of manager and project, you have this. So manager project is composed within manager, or manager is composed of project, whichever way you look at it. So if manager ceases to exist, so if an instance of manager ceases to exist, then automatically the project instance of project also ceases to exist. Okay, let us look at one more example, which is the pet shop and the groomer. So pet shop has a groomer instance, and now if you are creating the instance of the groomer within the pet shop, so again there is this composition relationship, right? So if instance of pet shop ceases to exist, then the groomer automatically dies. So let's say the groomer is working exclusively in one particular pet shop, right? So the groomer doesn't work for multiple different clients. So there's only one client, so to say, or one employer, which is one particular pet shop, P1. So if P1 gets shut down, then the groomer is out of business. So the groomer is now unemployed. So you can treat it that way, right? So is that clear? Or are there any questions here? Okay. So if yeah, there are no questions, I move on. So next
So
one.
what if a class is instantiated in two other classes?
Yeah. Then there those are different instances, right? So let's say pet shop. So groomer is part of pet shop, and then now you are creating two instances of pet shop, P1 and P2. So within P1, you are creating one new instance of groomer, say G1, and in P2 also a new instance of groomer gets created, which is G2. And there is no relationship between G1 and G2. Is
So
that what you
I
asked?
was asking, sir, if there was a class other than pet shop which was instantiating uh, uh,
No,
dog
groomer.
dog instance, then will we say also will both the classes be said as containing the class dog?
Yes, yeah. So more than one class can be composed with the same other class, right? So that's okay. So there is a pet shop class that is composed of groomer, and then there's also a I don't know, let's say zoo, for example, zoo, and that is also composed of uh, say dog groomer.
Okay, sir. And sir, if inside this test groomer method, we are calling another class, we are calling a method of another class which stores uh, the variable Django inside an array of another class. So even after uh, the execution of test groomer ends, the instance of Django will still be inside the other class method. So doesn't it contradict the statement that after the execution of this test groomer ends, the object Django will also be garbage collected?
So I didn't completely follow the array part.
So like in this question, in this method, the instance Django is created, and then inside this method only, a method of another class say zoo is called, which stores the function of that method is that it will store the object passed into it into an instance into a class variable of this that other class zoo say. list of animals. Say the list is the list of animals. So even after the execution of test groomer has ended, the this Django object will still be inside the array of the other class. So will we say that this object is garbage collected?
Okay, so within test groomer, you are using the instance of say zoo, and then you are passing the value of say Django or say groomer to it, right? Is that what you asked?
Yes.
Okay, so okay. Um, so you are creating this groomer here, but you are passing it to a different class and then asking that class to
Store it.
store it.
Yes.
Yeah, yeah. In that sense, okay. So yeah, that's right. So if you again like, so if there are any pointers to that memory location which are active, then it cannot be garbage collected. So that statement holds true. Um, so here, what happens here is, so if there is no other, yeah, that's a corner case, I guess, so to say. So if there are no more references to the groomer, then the life cycle of a groomer will end with the life of pet shop, right? So if there's a P1 and then there's a G1 groomer, which is the instance of dog groomer. So if you end the life of P1, then automatically a groomer's life would also end. If there are no other references to the same memory location. Yeah, you're right. So in that sense, that's a corner case. Okay, so shall I move on?
So, sir, if we do not instantiate the contained class
Hmm.
inside the container class, so will it still be called composition?
No. So that is the association. So we'll come to that in the next couple of slides, right? So if you don't instantiate it, but let's say you're using you have uh, you have an instance variable um, which is the variable of a particular user-defined data type, and that happens to be a class. Uh, but if you are not instantiating it within the constructor of this particular class pet shop, then it's not called composition.
Sir, another doubt. So, let's just suppose that the pet shop and the groomer have a many-to-many relationship. Like a pet shop has multiple groomers, and groomers can also work for multiple clients. Then, in that case, you can't call it a composition, right? Because if the particular object of pet shop gets deleted, those other objects of groomers will still exist, right?
Yes. Yes. So, um, but then if you are, so within groomer, yeah, you would be creating multiple instances of pet shops for all the pet shops that they are catering to. And here you would again create multiple groomers. For each pet shop can have multiple groomers. Um,
Yes,
yeah,
sir.
but
So
what was the
suppose both of these classes again have an array. This pet shop has an array of groomers, and the groomer class has an array of pet shops that
Hmm,
that
hmm, hmm,
particular groomer works for.
hmm, hmm.
So suppose now my pet shop instance gets deleted. So obviously the array inside will also get deleted because it was a member. But when we go to the groomer instance, it just it would no longer be pointing to that particular pet shop object, right? I mean that's it. It still exists in the memory.
Yeah, so the example that was given by one of the earlier students is this array list now exists in a different class. So it's neither pet shop nor groomer, but let's say it's a different class called zoo or something. now that holds all these references to all these classes, sorry, objects in an array list. So that's when you have the corner case, so to say, where even though you eliminate the references to that particular memory location from here, it will still exist because there is a different class that holds all these memory locations. So, yeah, so in that case, it's not a complete wipe out of all the references.
Okay, sir. All
But
right.
in
Thank
the
you.
class, yeah, in the example that you said, so let's say a pet shop P1 has multiple groomers. So if P1 ceases to exist, then all the groomers that are associated with that particular pet shop, at least it is that part is gone, right? So let's say groomer G1 now works at P1, P2, P3, three pet shops. So if P1 no longer exists, then the groomer now works at only two locations, G1 and G2 and G3.
Yes,
So you
sir.
can treat
Yeah.
it that. Yeah.
So, sir, with respect to pet shop, it will still be a composition because if
Yes, yes. So,
you,
so
yeah.
as long as you create the instance within the constructor, right? So it is a composition.
Okay, sir. All right. Okay, thanks.
Excuse me, sir. I had a
Yes,
doubt in this for the composition relationship. So,
yes.
so the object Django of class dog is created by a method which is called by the constructor of pet shop, right? So,
Hmm.
can we say, is it true that the class dog and the class pet shop will also share a composition relationship? Because the class Django is not
Oh, this one. No, no, because it's a local variable, right?
yeah.
Local variable will anyway get destroyed at the end of this method.
Okay. Okay. So
So it has to be the first prerequisite. It should be an instance level variable,
okay. Okay.
and then yeah, it should be created in the constructor.
Okay. Thank you.
Excuse me, sir.
Yeah.
So I would like to ask I would like to ask something about the corner cases you were talking about the questions asked by Meher and the person before that.
Okay.
Could we, okay, so the way I thought it was, whenever we instantiate an object, so in essence, we are creating a pointer to a memory location, right? So,
Yeah, that is right.
like in that example, when they were saying that, like a groomer has an array of pet shop and a pet shop has an array of groomer. So, when garbage collection for pet shop happens, I would say that the pointer present inside the pet shop is garbage collected, but the data stored at the memory location which that pointer was pointing to, that is not garbage collected. That would only be garbage collected if there is no pointer existing that points there.
Yeah, that's right. Yeah, that's what I said. So let's say the where was
But sir, shouldn't
yeah here? So
the instant variable end along with the class? It should not exist after the garbage collection of the container class.
okay, so let me answer the previous question first, and then come to this one. Um, so let's say something is garbage collected only if there are no active references to a particular memory location, right? Let's see. So in this case, you had Django here, which was pointing to this memory location, let's say 1001, and later on Django is now pointing to 1002. So if it is sure that there is no other pointer to 1001, only in that case it's garbage collected. So the assumption that we okay, not the assumption, but let's say here if you go back and if we take a look at this, right? So if let's say P1 is an instance of pet shop, so if groomer, so the assumption is groomer is only getting used here, and groomer reference of groomer is not getting passed elsewhere, right? So there are no other pointers to this particular memory location, which only now which has only one pointer, which is that of groomer, right? So if P1 dies, the only reference to groomer also dies with it. So that's why groomer also gets garbage collected. But if you are passing this groomer elsewhere, and yeah, then there will be more than one references to groomer, right? So there's an array list that holds a list of groomers, and you can anytime access the values of this array list. So as long as the array list is active, there are pointers to groomer, this particular groomer. So in that case, yeah, it cannot get garbage collected because there's at least one reference which is active and pointing to that particular memory location. Yeah. So does that answer your question? And are there more questions?
Yes, sir. Thank you.
Okay. So shall I move on to the next one?
Doubt. So if we consider three classes, let's say pet shop and pet shop and the groomer class, and we consider another class which composed of the groomer class. So, sir, the instance of the pet shop can access the third class or not?
Sorry. So can you repeat? So you have three classes, and then what happens?
If we take example in which there are three classes consisting of the pet shop class and the groomer class and the third class, in which pet shop class is the pet contains the the groomer class, and the groomer class contains the third class. So can a object of the pet class, when we create an object in the pet class, can access the third containing class?
Not directly, right? So if it doesn't have a instance here, then it cannot contact the one that is at 2 levels deep. So only groomer can contact. So pet shop, the instance of pet shop, let's say P1 can contact G1, which is a instance of dog groomer. And if it's a third class called T1, so G1 can contact T1, but unless there is a link or a instance, P1 cannot contact T1 directly. Right?
Okay, sir.
So are there, shall I move on? Okay, so the second type of relationship is what is called as association. So in association, it knows about the other instance. So instance of A knows about the instance of B, but it does not instantiate it. So it's not tied up to the extent that we have seen in the composition, right? So in composition, it's tied up pretty closely with each other. Like I said, so the example is a car is engine is part of a car. So there's an instance of engine, say E1, which should be part of the instance of car C1. But in this case, it just knows about the other instance, which is B. So when we look at the example, we'll get to know. But this is not as closely tied up. The relationship between these two instances, instance of A and instance of B, is not as closely tied up as it is in the case of composition. And even in terms of, so since it's not very closely tied up, the lifetime of instance of A and B is also different, right? They have their own lifetime and they can exist without each other. So let's say instance of A dies, then the instance of B does not die with it, so it can live as long as required, right? So in terms of the UML diagrams, you have a simple arrow, solid arrow with a direction. So the direction is from A. So A holds a reference of B. So A is associated with B. Okay, so let's jump to an example here, and I think so that will make it clear. So let's say we have a project and a contractor who is working on that project. So now every contractor should work on some project. So that's why you create an instance of or have an instance variable of project here in the contractor, right? And as part of the constructor, so you don't instantiate it here, but you are simply asking for a reference. So someone else creates the instance of project, and that instance is simply passed as value, as one of the arguments, right? And you are simply assigning it here. So that's why if let's say contractor expires, the instance of contractor is garbage collected, let's say C1, which is instance of contractor, dies or garbage gets garbage collected, P1 still exists. P1 is an instance of project, right? Because you did not create it within this particular class. So if you had created it within this constructor, then the scope of that is restricted to this particular object, right? But since you did not create it within this particular constructor, the scope is not restricted to it, and it does not die with the instance of contractor. So this is the difference between association and composition. And in terms of the UML diagrams, this is how you do it. So you have the contractor class, the box for the contractor, the box for the project. So the first row is that of the instance variables, and the first subsequent rows would be that of the methods. So it's a simple line dash, sorry, simple solid line. Yes.
Hello, sir. I want to ask a question that if the instance of the contractor class dies, then how are we going to access these functions like set project and all?
No.
I mean,
So that is sort of independent of the class relationship, right? So let's say you have instance of contractor C1. So if C1 dies, there is no way to access the C1's state and C1's methods.
yeah.
But if you have C1, C2, C3, then you can
Multiple constructor, objects.
Yeah, if there are multiple objects, then you can still access the C1 dice, but C2 and C3 are alive. So then you can make use of C2 and C3.
Thank you, sir.
So is the difference clear? So here you are not instantiating it in the constructor, and you are simply taking the reference as a argument.
Sir,
Yes.
so like we assign project to current project, and if I make any changes to current project, would that be reflected to project as well?
Yes. So we discussed that earlier, right? So for example, if you now somewhere here you say current project dot name or current project dot set name equals whatever. Let's say instead of 101, you have 102. So earlier it was 101, and now you change it to 102. So when you look at the values of project as well, which is PROJ or whatever this is on the side of this method, right? So whenever the method is called, let's say the object that is passed is P1. So P1's value will also get changed.
And sir, if we in like at any point of time, if we delete the real instance of PROJ, so that means the current project will also get null.
No. So again, so you have now two references, right? So we have seen that in the previous lecture. So
Okay, so only the reference is deleted.
yeah, one of them gets deleted. So here we had some time back we had that, right? Shaggy dog.
Yeah,
This one.
yes, sir.
So now similar to this, there are two references. So even the project would have two references to it. So if you delete one of them, delete in the sense, let's say this one dies, but there is still one reference to this location, so it does not get garbage.
Okay, thank you, sir.
So let's move on to this one. So in this case, it knows about the other instance. So A knows about the instance of B, but it cannot dictate the lifetime of B, right? So instance of B. So that's one of the major, that's the major difference between composition and association. So in that sense, it's not a component of, so B is not a component of A. Okay, so so now that we have the instance of uh, there should be an instance variable here. I think okay, that has been skipped because of the lack of space, right? So first thing that you do here is create again instance variable. Let's say dog. So if you want to make dog as an associate of dog groomer, so you create an instance of dog here, instance variable, and then within this constructor you instantiate the dog. Sorry, you don't instantiate. Sorry, you simply pass in the reference and then you can assign it. So if you instantiate it, that becomes the composition. And then yeah, so in different methods you can keep using the dog instance. But if that is not the case, let's say if you don't want to make it as an instance variable and you want to restrict the scope of this shaggy dog only within this method, then you can do it locally, right? So now the scope of this shaggy dog is only within this particular method. So the question that was asked here is, what if the dog groomer now wants to send a message to the pet shop? So pet shop has an instance of dog groomer, but dog groomer does not know about the pet shop, right? At least so far. So in order for the dog groomer to know about pet shop, there has to be an instance of pet shop also in the dog groomer class. So that is what we'll be looking at in the next couple of slides. So there's an association between, there's a one-way association, so to say. So pet shop knows about dog groomer, but the dog groomer does not know about pet shop. So in order to have the two-way association, we need to have the instances created within dog groomer as well. So when you create an instance of pet shop in the dog groomer, now there's a two-way association. So pet shop knows about dog groomer, and dog groomer also now knows about the pet shop. Right. So far we have not yet used any methods of the pet shop, and but we will do that in the next couple of slides. Yeah, I said a question. Okay. So the first step, like I said, is to make this declaration, and in the second step, you want to create this association, right? And in order to create this association, you do it through the constructor. So you pass in the instance as an argument, and then you make this assignment. Okay? So that creates this association between dog groomer and pet shop. And now you want to create the reverse association. So you want to say that even dog groomer should be associated with the pet shop. So you create an instance of pet shop here, and then make this association. And now the pet shop knows about dog groomer knows about the pet shop. But there is a slight difference, right? So if you look at it from the pet shop point of view, it is a composition because you are creating an instance of dog groomer here. But if you look at it from the dog groomer's point of view, it's an association. So although both know each other, the relationship is slightly different. So one is a composition, the other one is an association. Right? So is this clear?
Excuse me, sir.
Yeah.
So why is there a underscore in the name of pet shop in the private variable? Is it just a naming convention, or is there something special to it?
No, it's just there's nothing significant here, right? So generally, okay, so I can't completely say it's a naming convention, but some of the programmers follow this convention. So the naming convention is that you should start with a small letter. Like I said earlier, it should be a lower camel case. So if there are multiple words as part of the variable, so here there are two words as part of the variable, right? One is pet and the other one is shop. So you combine them together, but the starting letter of the first word should be small, and the starting letter of the rest of the word should be capital. So like S here is capital. Now the same holds true for the classes as well, class names. So you should combine the multiple words, except that the first letter of the first word should also be capital, along with the first letter of the other words. So everything should be capital. So this is the camel case, regular camel case, and this is the what is it called, the lower case camel case, lower camel case. Yeah. But it doesn't have any significance. Okay. So are there any other questions?
Sir, uh, if we access the members of the class pet shop, the static members of the class pet shop inside dog groomers without even creating a uh, object of pet shop, then will it still be association?
So that's okay. So generally it's not considered a good practice, like I said, to okay, I'll get to that, but okay, let me just give out the good practice and then I'll answer. So so it's not a good practice to directly use the variables, right? So avoid using static variables as much as you can unless it's really required. And then the second point is, if you the way to access these variables is through the accessors or mutators. So use the getters or setters, make the variable private and use getters and setters. So that's the way to, that's the good practice. And now, yeah, to the question. So yeah, so if you use class dot static variables, no, that is not an association. So there is some, again, relationship between these two. Yeah, that's a good question. So yeah, you're not creating them, so it's not a composition. And if you, okay, and if you delete, or if, let's say if the instance of, let's say, P1 pet shop dies, then the static variable still remains, right? So in that sense, it's an association. Yeah. So yes, so it's to answer your question, yeah, it is an association, because they are, now you are relating those two classes with each other, and it's not, so if one dies, the